Hello students, this book Inspire Physics for grade 10 advanced, and in this book the chapter 1 is vibration and waves. In chapter 1 there are 3 lessons. Lesson 1 is periodic motion, and in this video I am going to discuss all the questions. Okay, we will be solving all the questions given at the end of the first lesson, that is periodic motion. I am Amir Shahjan. Welcome to Mass Academy. We will start. In this question, a spring stretches by 18 centimeter when a bag of potatoes weighing 56 Newton is suspended from its ends. So to solve numerical questions in physics, there are 3 steps, right? So the step 1 is analyze the question. Analyze question means write what is given in the question. When you read the question, write what is given in the question. So a spring stretches by 18 centimeter. What is given? The distance is given, right? The distance through which the spring is stretching. Here this was the equilibrium position of the spring. When the potato is added, or when the bag is added by applying a force here, so the length of the spring is increased by 18 centimeter. So x is equal to 18 centimeter, but 18 centimeter is not the SI unit of distance. SI unit of distance is meter, so we have to change this 18 centimeter to meter. How? Dividing by 100, right? So 18 divided by 100. When you divide this, you will get 1.8 meters. What else is given in this question? The weight is given, right? Means how much force is applying here. How much force is applying? The 56 Newton force, right? That is the weight. How much weight is acting on the spring? That is equal to 56 newtons of force is given. 56 Newton is the force. What do you have to calculate? You need to calculate a spring stretches by this. Okay, so you need to calculate. There are 2 questions in the textbook. Question A, determine the spring constant, and question B, how much elastic potential energy is stored in the spring. So A, we have to calculate the spring constant K. Spring constant K we have to calculate. So we have to calculate K is equal to what? So K means the spring constant. Okay, calculate A spring constant of the spring, and B, we need to calculate the elastic potential energy stored in the spring. Elastic potential energy stored in the spring. So we have X, we have force, and we need to calculate K, the spring constant. Then you have to find an equation, or you have to look for an equation which connect all these terms. Means an equation in that X should be there, F must be there, and K must be there. Means we need to calculate K, right? So K must be there in that equation. So which equation? Connect all these things. We know that Hooke's law equation, right? The Hooke's law equation, F is equal to minus Kx. I am not writing minus sign for the calculation because no need for minus sign, just to means, or just to represent the force and X are in the opposite direction. Force and X are in the opposite direction, and when you apply the values, the minus will be cancelled. So I am not writing the negative sign. You also do not have to write the negative sign while doing the calculation. While solving the numerical problems, you don't have to use that negative sign. So F is equal to Kx. F is how much? 56 Newton. And K, we need to calculate. X, the distance, how much? 0.18, right? So 0.18. I need to calculate K. So K is equal to, I will keep this K here. I will keep this K here, and this one, this 0.18 has to cross this bridge. This equal to sign, that we will say bridge. So this 0.18 has to cross the bridge. When anything cross the bridge, it cross like this, right? Whatever it is in the numerator of the equation, means whatever that is the multiplication in the equation, so it will become division. Numerator will change to a denominator, or we can say up will go down. So K is equal to 56 divided by 0.18, how much? 56 divided by, calculate and tell the answer. Where is switch on? Yes, 56 divided by 0.18, which equals how much? 311. So the answer is 311. Answer is equal to 311. What is the SI unit for K? So K, you can see here from this equation. If I write equation for K, K is equal to F divided by X, right? So K is equal to F by X. What is the unit of F? Newton. Force is Newton, and this is distance. Unit of distance is meter. So unit of K will be Newton per meter. Newton per meter, that is the SI unit for K. So we have calculated the spring constant K. Now we need to calculate the elastic potential energy, that is question B. Elastic potential energy, how to calculate? We have this equation to calculate elastic potential energy. Elastic potential energy of spring, that is equal to half kx squared, right? Half kx squared. So I will erase this. So elastic potential energy, question B, elastic potential energy, that is equal to half kx squared, half multiplied 311. K you already calculated, x value, that is 0.18 squared, which equals 0.5 multiplied 311 multiplied 0.18 squared, which equals 5.038. So 5.0 joule. SI unit of elastic potential energy or SI unit of any type of energy is joule. So 5 joule, we done with that question. Then we will move to the next question, okay, from the practice problems. So in this question, what is the spring constant of a spring that stretches 12 centimeter when an object weighing 24 Newton is hung from it? So what is given? First step is, when we read the question, we need to write what is given in the question. That is called analyzing the question. So 12 centimeter is given. What is 12 centimeter? It must be distance, right? It must be x. So x is equal to 12 centimeter, but centimeter is not the unit of distance. Meter is the SI unit of distance. So we need to change this 12 centimeter to meter by dividing by 100. So it will be 0.12 meter. Then what else is given? When an object weighing 24 Newton, Newton is unit of force, right? So force is given. You can know which quantity is given from its unit. Here 24 Newton is unit of force. So it must be force given. The magnitude of force is 24 Newton, and we have to calculate K, right? We need to calculate what is the spring constant. So spring constant we represent by letter K. You need to calculate K. Then look for an equation that connect X, F and K. Just discussed before, there is an equation, that is Hooke's law equation, which connect all the three: force, spring constant, X. So spring constant K is equal to F divided by X. X will cross the bridge, K will be there, X will cross the bridge, so X will come down, right? So K is equal to F by X. The value of force is 24 Newton. So 24 divided by 0.12 equals how much? 24 divided by 0.12 equals 200. So 200 Newton per meter is the value of the spring constant. Second question, what is the elastic potential energy of a spring? We need to calculate the elastic potential energy. And what is given in the question? The spring constant. With the spring constant K is equal to 144. So spring constant K given. K is equal to 144, unit is Newton per meter. And how much is x given in the question? X is given 16.5 centimeter, right? The spring is compressed by 16.5 centimeter. So 16.5 divided by 100, that is equal to 0.165. Why did I divide by 100? Because 16.5 is given in centimeter, not the SI unit of length. SI unit of length is meter, so 0.165. And we need to calculate the elastic potential energy. Elastic potential energy, big question mark. You need to calculate that. So look for an equation that connect all the three. Learn the equation, by heart the equation. Okay, no need to ask will equation be given in the exam. So you can remember the equation elastic potential energy, that is equal to half kx squared. So half multiplied k, the value of spring constant. How much? The value of spring constant is 144 multiplied 0.165 squared, which equals 0.5 multiplied 144 multiplied what? 0.165 squared, 1.96. So 1.96 is joule, right? Joule is the SI unit. 1.96 joule. Joule is the SI unit for all types of energy and work. So this is the question number 3 from practice problems. A spring has a spring constant of 56 Newton per meter. How far will a block weighing 80 Newton stretches it? So what is given in the question? 56 Newton per meter is given. What is Newton per meter? Newton per meter is the SI unit of spring constant. So spring constant K is given, that is equal to 56 Newton per meter. How far will a block weighing 18 Newton? So Newton is unit of force, right? So F force is 18 Newton, that also given. What do you have to calculate? How far? Means you need to calculate the distance, right? You need to calculate the increase in length of the spring or extension of the spring. So x is the increase in length, or we say the distance or the displacement or the extension, means how much the length of the spring is increased. That is what we have to calculate in this question. So look for an equation that connect all the three Hooke's law equation, right? Kfx. So F is equal to Kx, and you need to calculate x. How much is the value of force? 18. That is equal to 18. Force is equal to K is given 56. K 56 and x you need to calculate. So x will cross this bridge. When x cross the bridge, it will go down, right? So like this it go. No, x we need to calculate, right? So x I will keep here. This 56 will cross the bridge. So x will be here. X is equal to 18 divided by 56. So x is equal to 18 divided by 56. How much is 18 by 56? 18 divided by 56, that is equal to 0.32. So 0.32 meter is the extension in the spring. Means how much? The length of the spring is increased. The length of the spring is increased by 0.32 meters. Question number 4, challenge. But it's a very simple question. There is nothing challenging in this. A spring has a spring constant of 256 Newton. So spring constant is given. How much? 256 Newton, right? K equal to 256 Newton per meter. Newton per meter, okay, not Newton. Newton per meter is the SI unit for spring constant. How far must it be? How far means we need to calculate the distance, right? We need to calculate the distance. We need to calculate. So to give it an elastic potential energy, is also given 48 joule. 48 joule is the elastic potential energy. So to give the spring an elastic potential energy of 48 joule, how much the spring has to be stretched? How much or how much the length of the spring has to be increased, and the spring constant of the spring is 256 Newton. Here in this question the spring has a larger spring constant, right, compared to the previous question, 256 Newton. So larger spring constant means the spring is strong, okay, or we can say rigid or hard. It is difficult to stretch. If the spring constant is greater, which means we need to apply more force to stretch it. The spring is hard, means it's not easy to stretch, it is difficult to stretch. We have to apply a larger force to stretch the spring. And if the spring constant is less, means if it is a very low value, the spring is like a soft one, we can easily stretch it. So here the spring constant, its value is 256 Newton, and we need to calculate. So which equation that connect all these three? We have the equation elastic potential energy of a spring, that is equal to half kx squared, right? We need to calculate what? We need to calculate x, we need to calculate the distance. So elastic potential energy, that is equal to 48, which is equal to 1 by 2 multiplied k value is how much? K value is 256 and x squared. So I will just keep this x squared here, and all these 1 by 2 and 256 will cross this bridge. So when they cross, they always cross like this, okay? When anything cross the bridge, they always cross like this, okay? Whatever in the numerator, that will go to the denominator, and whatever is in the denominator will go to the numerator. So for example, this become 48 is already here, and this 2 will go here. When they cross the bridge, they cross like it's crossing, right? Crossing. So 2 here divided by 256 here, that will be equal to x squared, right? So how much is the value of x squared? X squared, that is equal to 48 multiplied 2 divided by 256. So x squared is actually equal to what? 0.375. 0.375. We need x, right, not x squared. So x is equal to square root of 0.375, which equals square root answer equals 0.61. So 0.61 meter is the unit of distance, unit of length, or unit of extension. So 0.61 meter is the extension. If you stretch the spring, if you increase the length of the spring by 0.61 meter, so the energy stored in the spring will be equal to 48 joule. In this question, a physics challenge, in that a car is at a height of h is the height, and a car of mass m rests at the top of a hill of height h before rolling without friction into a crash barrier located at the bottom of the hill. The crash barrier contains a spring with a spring constant k, which is designed to be the car to rest with minimum damage. Determine in terms of m, h, k and g the maximum distance x the spring will be compressed when the car hits it. So we need to calculate the maximum compression that we need to calculate. No, we don't have to calculate, we have to express an equation for x. We have to create an equation for x in terms of m, h, k and g. In terms of m, h, k and g. So what is these things here? M is mass of the car, h is this height. M is mass of the car and h is the height of the hill, and the car is on that hill, at the top of that hill. So h is height of the hill. And what is k? K is spring constant of the spring. Spring constant is also called stiffness. Another name for spring constant is stiffness. And g is the gravitational constant. gravitational constant, gravitational field strength, right? So gravitational field strength or acceleration due to gravity. So I will just write gravity, okay, that much is enough. Okay, so you will understand, right? Gravity means what? 9.8 on the surface of the earth. Now you understand. So we need to calculate an equation for x. So what happens is here the car is at a height, right? Car is at a height h, so it will have a gravitational potential energy. That gravitational potential energy is equal to mgh, correct? mgh, that is the equation for gravitational potential energy, where m is the mass of the car, g is gravity, and h is the height of the hill, and the car is on the top of the hill. Okay, so here when the car is rolling down, means falling down or rolling down, whatever it is, the car is moving like this, so all its gravitational potential energy decreases and become kinetic energy. Gravitational potential energy GPE, gravitational potential energy changes to kinetic energy. So the car is moving very fast and it will hit the spring. When it hits the spring, what happens is the spring will be compressed and the speed decreases, right? The speed of the car decreases. So when speed of the car decreases, which means its kinetic energy is decreasing, and you know that energy cannot be destroyed, right? That is conservation of energy. Energy will change from one form to another. So kinetic energy decreases means kinetic energy is changing to another form of energy. So here the car will hit very fast on the spring and the spring will be compressed. So when the spring is compressed, energy will be stored in the spring, that is called elastic potential energy of the spring. Elastic potential energy of the spring. So what is the equation for the gravitational potential energy? mgh, right? This gravitational potential energy finally changed to the elastic potential energy of the spring. So what is the equation for elastic potential energy? Half kx squared, that is the equation for elastic potential energy. So from this we can write all the gravitational potential energy of the spring of the car, all the gravitational potential energy of the car initially the car has, that changed to the elastic potential energy of the spring when the car compresses the spring. So what happens, what I will write is the elastic potential energy, half kx squared stored in the spring, that is equal to the initial gravitational potential energy of the car mgh. So now we need equation for x, right? We need to write an equation for x. So x squared, which is equal to other things, this 2 and k will cross this bridge. When they cross the bridge, they cross like this, right? Like this. Okay, so it becomes 2 multiplied mgh divided by this k will go down here, but we need x, right? We need not x squared. X is equal to, take a square root here. So we got an equation, a formula for the extension or the compression, right? Compression of the spring in terms of m, g, h and k. So done. In that question 2, if the car rolls down a hill that is twice as height, by what factor will the spring compression increases? So where is my equation? We wrote an equation x, right? X is equal to what? Square root 2 mgh over k, right? 2 mgh over k, this is what we got. So if height of the hill is increased by 2 times, if the car is on a hill that is 2 times higher than the previous hill, means height is twice the previous height, so how much will be the compression? What will be the compression in the spring, or what factor the compression in the spring will increase? So we can see that the compression depends on the height, right? Compression, there is a height h in the equation of x, but h is inside the square root, right? So when you increase the height, okay, when you increase the height by 2 times, you are making it 2 times height. So what happens to x? So x will be increased to, because this h is inside the square root, right? H is inside the square root. So if we write it 2 here, 2 here, so that is inside the square root. So x will be increased by root 2 times. X will be increased, compression will be increased by root 2 times. For example, before the height was h, so how much is the compression? For example, compression is 5 centimeter. Now the height is increased by 2 times height. So how much will be the new compression? New compression will be equal to root 2 times the previous compression, that is 5. So how much is root 2 times 5? Square root 2 times 5 equals square root 2 equals what? Okay, times 5 equals 7.07. So it will be like this, 7.07 centimeter. Okay. In that question number 3, what will happen after the car has been brought to rest? So after the car has been brought to rest, what happens? The spring is completely compressed, right? The spring is maximum compressed. So now the car is at rest. The spring stretches, right? The spring stretches. It will apply its restoring force. So when the spring stretches, what happens is the car will go back. The car will be pushed backwards. Okay. So in that third question, what will happen to the car after it stopped, right? The car will be pushed back by the spring. The car will be pushed back by the spring. So the spring has elastic potential energy, right? When the spring is compressed, it has elastic potential energy. What is elastic potential energy? Elastic potential energy is the energy stored in the spring and it is ready to be released. The stored energy is ready to be released. So what happens is when the spring is completely completely compressed, so it will go back. The spring is elastic material, right? So every elastic material has a tendency to go back to its original shape and size. So the spring will push the car backward for the spring to regain its original shape. Now we are discussing questions from the topic pendulum. So there is an equation given to calculate the period of pendulum. The period of the pendulum t is equal to 2 pi into root of L by G. This is from page number 8 and resonance given. So we have some questions given in page number 9. First one, the example problem 2. Finding G using pendulum. Finding G means gravitational field strength, right? So the equation to calculate the time period of the pendulum t is equal to, so we will write the equation here. The equation to calculate time period of the pendulum t is equal to 2 pi into square root L over G. Now we are solving the example problem 2. Example problem 2. Page number 9. So in this question, a pendulum with a length of 36.9 centimeter, right? So what is given? The length of the pendulum is given. Length of the pendulum L is equal to 36.9 centimeter, but in calculation we need in SI unit, right? So we need in meter, so it will be 0.369. How did we get? By dividing by 100. Centimeter will change into meters by dividing by 100. Has a time period of the pendulum is given, that is 1.22 seconds. Second is the SI unit of time, so no need to change it. What is the gravitational field at the pendulum's location? So one of the use of the simple pendulum is to calculate the gravitational field, and we have to calculate gravitational field, right? So we have this equation. Okay, so we need to look for the equation that connect length of the pendulum, time period, and gravitational field. So we have that equation. We have already that equation for time period. T is equal to 2 pi into square root of L divided by G. We need to calculate this G, right? We need to calculate this G. But the thing is, G is all inside the square root, right? G is inside the square root. So we have to take it out of the square root, or we need to destroy this square root. We need to remove that square root. So to remove the square root, what we will do is we will square the equation. We will square all the equation. When you square the equation, the square will cancel the square root, or the square will remove the square root. So it becomes like this: t square is equal to, when we square the equation, we have to square each term in the equation. So when we square 2, it will be 4 pi squared. So the square root, when we square the square root will be removed, so it become L divided by G. The equation become like this. So we need to calculate what? We need to calculate G, right? So to calculate G, I will move G here. Okay, I will make the G cross the bridge. When G cross the bridge, it will go like this. So G will come here, G equal to, and T square also will cross the bridge. When T square cross the bridge, it will go like that. So G is equal to 4 pi square L over T squared. So 4 pi square multiplied L how much? 0.369, right? 0.369, correct, divided by T squared. T is 1.22. So 1.22 squared, use your calculator. 4 multiplied where? Okay, pi squared multiplied 0.369 over 1.22 squared, which equals 9.787. So 9.79 Newton per kilogram. That is a unit for gravitational field strength, or you can write meter per second squared also, because G is acceleration due to gravity. Now discussing the practice problems. Question number 5. What is the period on earth of a pendulum with a length of 1 meter? So what is given here? We have only one quantity given, that is 1 meter. What is 1 meter? Length of pendulum. Length L is equal to 1 meter. So it is given in the SI unit meter, so no need to change. What is the period on earth? So on earth, we know the value of G, right? On the surface of the earth, value of G, that is 9.81 Newton per kilogram, or meter per second squared. That is the value of G, and we need to calculate the time period. So time period of a pendulum depends only on the length and the value of G, right? We have the equation for time period. T is equal to 2 pi into square root L divided by G. So G will be a constant, right? G will be a constant on the surface of the earth. Its value is 9.8. So time period of a pendulum depends only on the length of the pendulum, only on the length of the pendulum. It does not depend on the mass of the pendulum, right? It does not depend on the mass of that pendulum bob, size of the pendulum bob. So the period means the time taken to complete one oscillation, right? The time taken to complete one cycle of its periodic motion. So 2 pi into square root L by G, 2 pi into square root L is 1 divided by 9.81, which equals, so square root 1 divided by 9.81 multiplied 2 multiplied pi. So 2 The time period is 2 seconds. I will write 2.0 seconds. Question number 6. How long must be a pendulum on the moon where G equal to 1.6 Newton per kilogram to have a period of 2 seconds, right? So what is given in this question? How long must be a pendulum on the moon? How long means, how long must be a pendulum on the moon means the length of the pendulum, right? So here length of the pendulum that we need to calculate, where on the moon the value of G, the value of gravitational field is 1.6 Newton per kilogram. To have a period of 2 seconds, right? To have a period, time period is equal to 2.0 second. We need to calculate length. So we will check for the equation that connect all the three. We know that, right? So time period T is equal to 2 pi into square root L over G. The thing is we need to calculate L. L is inside the square root, right? So L is inside the square root. We need to destroy the square root. We need to remove the square root. So to remove the square root, we will square the equation, okay? To destroy the square root, the square will destroy the square root. So when we square the equation, we have to square all the terms, each terms in the equation. So t square, 2 square is 4, pi squared, and this is removed, right? When we square this, the square will remove the square root, L over G. So we need to calculate L, so I will keep L here. And we will move everything, every other thing will cross the bridge. So t square is already here, t square is already there, the G will cross the bridge. So G will, when they cross the bridge, I told many times, when they cross the bridge, they cross like this, right? Like this, these people cross the bridge. So t square, the G will be, where is my black? Yeah. G will be here, multiplied G divided by this 4 pi square will come here, equal to L. So how much is L? L is equal to t square. What is the value of t square? 2, right? So 2 squared multiplied G, value of G on the moon is 1.6 divided by 4 pi squared. Two squared is 4 multiplied 1.6 over 4 multiplied pi squared equals 0.16. So 0.16 meter, right? That is the length. 0.16 meter is the length of the pendulum, which means 16 centimeter, right? The length of the pendulum should be 16 centimeter to have a period of 2 seconds on the moon. What is the value of G on the moon? 1.6, right? 1.6 Newton per kilogram. So the next question, on a certain planet, the period of 0.75 meter long pendulum is 1.8 seconds. So here what is given? The length of the pendulum is given, that is 0.75 meter. 0.75 meter, right? Meter is unit of length. So if anything given in meter, that will be length in this type of question. So here a long pendulum is, the period is also given 1.8 seconds. Second is unit of time, right? Unit of time. So if anything given in second, that will be time. So time period here it is 1.8 second, and we need to calculate the value of G. So we will use the same equation. Time period is equal to 2 pi into square root L by G. So here we need to calculate G, but G is inside the square root. We need to remove the square root by squaring the equation. So t square, that is equal to 4 pi square L divided by G. We need to calculate G. So G will cross the bridge and will come here. So it will be equal to 4 pi square L over t square, which is equal to 4 pi square L is equal to 0.75 divided by t square. The value of t is 1.8, so 1.8 squared, which equals, so what's the answer? You can calculate 4 multiplied shift pi squared multiplied 0.75 over 1.8 squared equals 9.1. So on that planet the gravitational field is 9.1 Newton per kilogram. It is just less compared to the gravitational field on the surface of the earth. In page number 9, the next question, check your progress in that part, periodic motion. Explain why a pendulum is an example of periodic motion. Because a periodic motion means an object that repeats its motion after equal time interval. If any motion that repeats its path after equal time interval, that is called the periodic motion. So a pendulum oscillates like this, right? The swing, example, the swing in the park. So after a time interval, the pendulum repeats its path, that is called periodic motion. So question number 9, energy of a spring. The spring in figure are identical. Contrast the potential energy of the bottom spring. So here first spring 1 is the equilibrium, and spring 2 the extension is 2 centimeter, and the spring 3 the extension is 4 centimeter. So we need to compare the elastic potential energy in the second and third spring. So we have first one spring here like this. So this is at equilibrium, right? This is at equilibrium. So at equilibrium I will just write it is at equilibrium, so I will write EQ. So at equilibrium elastic potential energy of the spring will be equal to 0. Okay, at equilibrium the potential energy will be 0. Then what happens in the second spring? This is the second spring. The spring is extended, right? The spring is extended by how much? By 2 centimeter, and so there will be elastic potential energy. And here the spring is extended again. Now the spring is extended by, for example, here up to here, right? Yeah, 4 centimeter. So more extension means more length, more stretched, right? So more potential energy, because when we stretch a spring, I am applying a force on the spring. To stretch the spring means I am spending my energy. So energy cannot be destroyed, right? Thus the energy I am spending, that will be stored inside the spring, within the spring, as its elastic potential energy. So if I stretch it more, I need to apply more force, means I am spending more energy. So more energy will be stored in the spring. So potential energy, elastic potential energy will be greater in the third spring compared to the elastic potential energy of the second spring. So how much? We have the equation elastic potential energy, that is equal to half kx squared. Means elastic potential energy of a spring is directly proportional to x squared. Means it is not directly proportional to x, it is directly proportional to x squared. So if anything is directly proportional to x squared, for example, if you increase x by 2 times, then elastic potential energy will be increased by 2 square times. 2 square is 4, right? Elastic potential energy will be increased by 2 square times. 2 square is 4. So elastic potential energy will be increased by 4 times. Why? Because elastic potential energy depends on the square of the extension, square of the increase in length, square of the distance of the spring, right? Distance through which we are stretching the spring, means we are increasing the length of the spring. So if you increase the length of the spring 3 times, so how much the elastic potential energy will be increased? Elastic potential energy will be increased by 3 square times. So what is 3 square? Elastic potential energy will be increased by 3 square times. 3 square times means 9. Okay, so how to compare the elastic potential energy between these two springs? The elastic potential energy of spring 3 will be 4 times greater than the elastic potential energy of spring 2. Why? Because the extension, means the increase in length of spring 2 is 2 times greater than the increasing length of the spring 2. Increasing length of spring 2 is 2 centimeter and increasing length of spring 3 is 4 centimeter. Means increase in length of the third spring is 2 times greater than the increase in length of the second spring. So its elastic potential energy will be increased by 4 times. So I will just write like that: elastic potential energy of third spring will be or is 4 times greater than what? 4 times greater than the elastic potential energy of spring 2. I am sorry if you are not able to the end of the board, bottom of the board. Okay, done. Then question number 10, in that Hooke's law, objects of various weights are hung from a rubber band that is suspended from a hook. The weights of the objects are plotted on a graph against the stretch of the rubber band. How can you tell from the graph whether the rubber band obey Hooke's law or not? So Hooke's law graph. What is Hooke's law graph? A graph which has y-axis and x-axis. On y-axis what? On a Hooke's law graph, y-axis, on y-axis force will be plotted, and on the x-axis distance will be plotted on the x-axis, and the graph will be like this. A Hooke's law graph will be a straight line. A Hooke's law graph will be a straight line. A Hooke's law graph will be a straight line. So if any material obey Hooke's law, and if you plot a graph of force against distance, the graph will be a straight line. If we plot a graph of force against the increase in length of the spring or increase in length of any material, the graph will be a straight line if the material obey Hooke's law. But in the case of rubber band, if you plot a graph of the force against the extension for a rubber band, the graph will be like this. Or only for extension I will draw like this, which means the graph is not a straight line for rubber band. If force distance graph is not a straight line, which means the object or the substance does not obey Hooke's law. So rubber band does not obey Hooke's law. How do we understand? We understand from the graph. How do we understand from the graph? Because graph is not a straight line. If it obey Hooke's law, if any object obey Hooke's law, graph must be a straight line. Question number 11, pendulum. How must the length of pendulum be changed to double its period? How must the length be changed to half the period? So how must the length of a pendulum be changed to double its period, and how must the length of the pendulum be changed to half its period? So time period of a pendulum is given by the equation 2 pi into square root L divided by G. So L is inside the square root, right? L is inside the square root. So you want to double the period, and the time period of a pendulum depends only on the length of the pendulum. So if you want to increase the time period, you need to increase the length. If you want to increase the time period, you need to increase the length. Sure? You understand that? If you need to increase the time period of the pendulum, you need to increase the length of the pendulum. But see, the length is inside the square root, right? So if you want to increase time period by 2 times, then you need to increase the length by 4 times. Why? Because length is inside the square root. So what is square root of 4? You check. Square root of 4, that is equal to 2. Square root of 4 is equal to 2. So as length is inside the square root, you have to increase the length by 4 times, then only period will be increased by 2 times. Suppose you want to increase the time period by 3 times, you want to increase the time period 3x, means 3 times. So you need to increase the length by 3 square times. You need to increase the length by 3 square times. How much is 3 square? 3 square is equal to 9, right? So you need to increase the length by 9 times, then only period will be increased by 3 times, because the length is inside the square root. Okay, because the length is inside the square root. Then to half the time period, how much you need to decrease the length, right? So to reduce time period, if you want to reduce time period, you have to decrease the length of the pendulum. You need to reduce the length of the pendulum. So if you want to make it 1/2 times, means you want to decrease the period by half, means you want to reduce it to half. So you have to reduce the length by how much? By 1/4. Reduce the length by 1/4. For example, if the length is before 100 centimeter and you want to reduce the time period, so you need to you want to reduce the time period, so you have to reduce the length. If you want to reduce the time period to half, then you have to reduce the length to 100 divided by 4, that is equal to 25 centimeter, right? 25 centimeter, like that. Okay, because L is inside the square root, as it is inside the square root, you need to reduce length by length divided by 4, because for example, if you take square root of 1 divided by 4, that will be equal to 1/2. Okay, like that. The next question is about question number 12. Okay, question number 12, resonance. If a car's wheel is out of balance, the car will shake strongly at a specific speed, but not at a higher speed or a lower speed. So not at a higher speed or a lower speed, right? At a specific speed, the car's body vibrate faster. Why vibrate faster at a specific speed? Because of resonance, right? Because of resonance. So question number 12, resonance. Okay, what is the meaning of resonance? Resonance means equal frequency. Resonance means equal frequency. Equal frequency. For example, when an object is vibrating, when its frequency of vibration become equal to the natural frequency of the other object, so maximum energy will be transferred from the vibrating object to the other object. So resonance is equal frequency. Okay, equal frequency, that is the meaning of resonance. Every object has its own natural frequency. Natural frequency is also called resonant frequency. So every object has a natural frequency. Every object has a natural frequency. And for example, here we have two objects here. This is object 1 and this is object 2. Object 1 and object 2, and for example, they are in contact. Object 1 and object 2, they are in contact. So this is our object 2, and this object 1 is for example rotating or vibrating, so it is in periodic motion, right? So every periodic motion will have a frequency. Frequency means number of rotations per second, right? How many times it is rotating per second. So if the wheel is rotating 50 times in 1 second, so its frequency is 50. So every object will have a natural frequency. So this object, the second object, has a natural frequency. So it has a natural frequency. I will just write n for the natural frequency. It's also called resonant frequency. Then if this first object is vibrating at a frequency that is equal to natural frequency of the second object, so what happens is all the energy or maximum energy will be transferred to the second object, that is called resonance. That is called resonance. For example, here in this question number 12, I am very good drawing car. Okay, only one tire. Yes, this car, the wheel is rotating, right? So it has a rotational frequency. The wheel is rotating, it has a rotational frequency. For example, its rotational frequency is 50 hertz. It is rotating at a speed of 50 hertz, and the natural frequency of the car also 50 hertz. 50 hertz is the natural frequency of the car. So now the tire is rotating at a frequency that is equal to natural frequency of the car, right? The rotational frequency of the tire, become equal to, when it is equal to natural frequency of the car, maximum energy will be transferred to the car. So the car will vibrate faster, the car will shake faster. And if the speed is decreased, means, for example, now the rotational frequency of the tire is 40 hertz, means in 1 second the car tire is rotating 40 times, and the natural frequency of the car is 50 hertz, right? Now the rotational frequency is not equal to natural frequency of the car, so means only less energy will be transferred. Okay, if they are equal, when the rotational frequency and natural frequency become when the rotational frequency of the tire become equal to natural frequency of the car, then the frequency is matching, right? That is called resonance. Okay, during resonance what happens? Maximum energy will be transferred from the tire to the car. Now if it is rotating, the car reduced speed, now the rotational frequency is only 40 hertz. So 40 hertz is not equal to natural frequency of the car, because natural frequency of the car is 50 hertz. Now energy will not be transferred. Okay, energy will not be transferred from the tire to the car. And if the speed is increased above 50 hertz, means now if the rotational frequency of the car is 60 hertz, means the speed is increased and now the car tire is rotating 60 times in 1 second, still the rotational frequency of the car is not equal to rotational frequency of the tire is not equal to natural frequency of the car. So energy will not be transferred from the tire to the car. That is the reason at a particular speed, the car vibrates faster. The reason is at that speed the rotational frequency of the tire become equal to the natural frequency of the car. Then the last question number 13, how is a uniform circular motion similar to harmonic motion, and how are they different? How a uniform circular motion is similar to a harmonic motion, and how uniform circular motion is different from a harmonic motion. That is question number 13, last question of this lesson. See, a simple harmonic motion is a periodic motion. It is a periodic motion. A uniform circular motion is also periodic motion. That is how they are identical. That is how how they are related. That is how they are related. Both are periodic motion. A simple harmonic motion is a periodic motion, means it repeats its motion after each time interval. A uniform circular motion also repeat its path after equal time interval. That is how the simple harmonic motion and uniform circular motion are related. Both are periodic motion, and how they are different. So in uniform circular motion, in uniform circular motion, force is directed towards the center of the circular path, right? So if an object is moving along a circular path with a constant speed, the force will be always towards the center, right? The force will be acting always towards the center of the circular path. Okay, the direction of force is always towards the center of the circular path. But in the case of simple harmonic motion, the force will be always opposite to the displacement. In simple harmonic motion, force will be always directly proportional and opposite to displacement. So this you will learn in the definition of simple harmonic motion. Thank you students for watching this video. Good luck for all of you. Learn physics, and if you have any doubt in this lesson or in the subject physics, you can contact in that given number. You can contact in WhatsApp in the number I will give with the video. Thank you once again, all of you. Bye.